Hey there, everybody. Good afternoon. Come on in. Hello. Who wants a free t-shirt? Anybody? He'll take a free t-shirt. We've got free t-shirts. NVIDIA is hitting the stage right now. It's about a 15-minute talk. Come on in, grab a seat, take a break, and get a free t-shirt to top it off. Under your skin. Isn't that a song, Rory? I've got AI under my skin. All right, everybody, welcome in. We've got NVIDIA on the stage here. Come on in. We've got free t-shirts. We've got seats. You can bring your lunch. Come hang out with me. They're not running. Okay. Well, I'll tell you what. We've got something even better. Rory Kelleher is here from NVIDIA, and I'm going to hand it over to you and say, take it away, and rock star cheering.
Thank you very much, guys. Hope everyone's having a good reInvent. It's really awesome to see that artificial intelligence is such a central and core message here at reInvent this year. There's also a big week for announcements on the convergence of artificial intelligence in healthcare. So NVIDIA and GE Healthcare made an announcement that we're going to be bringing AI to over 500,000 medical devices around the globe. We also made an announcement with Nuance Communications on how we're going to be building an AI marketplace so that clinicians and data scientists can upload their medical imaging algorithms so that they can share it amongst hospitals around the globe as well. And also, Andrew Ng, one of the foremost thinkers in artificial intelligence and deep learning, just released a paper this week around how deep learning is going to be a powerful tool in improving end-of-life patient care. So my name is Rory Kelleher. I'm an enterprise account manager with NVIDIA. And over the past year, I've had the opportunity to meet with and learn from many business leaders, data scientists across the healthcare ecosystem. And so my job today is to walk you through many of those applications of AI in healthcare. And I can tell you this much, that we're just getting started. So first off, why do we care about healthcare? Well, excuse me, I'm going back a little bit. Why do we care about healthcare? Well, the reality is that everyone here in this room is going to have some type of medical event in their lives. And studies show that around 5% of us will experience some type of medical error. So 95% success rate. That's how healthcare does today. Let's put that in business terms for a moment. A 99.5% success rate at Logan Airport means that there's still 2 unsuccessful landings each day. A 99.5% success rate for the United States Postal Service means that there's still 20,000 lost parcels of mail each hour. So clearly we don't accept this in our everyday lives. Why would we accept it when it matters most with our own healthcare? So I'm sure many of you are familiar with why artificial intelligence has become very real over the past few years. We've had these artificial neural networks, these deep learning algorithms for probably 30 or 40 years. But what we didn't have 30 or 40 years ago was access to large amounts of data and then access to efficient and affordable computation power that's been made available by the GPU. And so in 2012, a group of computer scientists competing in an image recognition competition first basically used this recipe. So they took these algorithms, they used large amounts of data to train these models, and they used the efficient and affordable computation power to get this done in a meaningful amount of time. And for the first time, we've had a computer system that was able to achieve higher than human level recognition capabilities. And this is what's given life to. This is really the big bang of machine learning and why we're seeing things like self-driving cars, recommendation engines, sentiment analysis. And there's a few reasons why we're particularly excited about deep learning. I think first and foremost is performance. Deep learning has proven to be better performing than many of the traditional machine learning models out there, especially when we have large amounts of data. Second is that deep learning has given birth to this completely new computing model, where in the past we always had to have a human, a data scientist, a data engineer doing the feature engineering, actually telling the model what elements of that data are most important to do a specific AI task. With deep learning, it's different. We've got a training data set. Sorry about that. So, yeah, I think we're good. So with deep learning, we've got a training data set. We use that training data set to obviously train the model. And once we've tested and validated that model, we want to deploy it to do inference. And inference can take place on a server in your data center. It can take place on a smart device like your cell phone, or it can take place on an autonomous machine like a robot or like a self-driving car. And as these machines are out in the real world, they'll come across new data, feed that back into the training data set, and use that to continue to improve the model performance over time. So it's really an example of software writing software. And I think for many years we've heard how software is eating the world. Well, at NVIDIA, we believe that artificial intelligence will actually eat software. So why are we excited about deep learning in healthcare? Well, healthcare has one of the major ingredients for success with a deep learning project, which is massive amounts of data. So genomics is one of those fields that's actually quite difficult for me to wrap my head around. How could we possibly begin to understand the 3 billion lines of code that make us who we are without the help of tools like machine learning and deep learning? 90% of the overall volume of medical imaging today, of medical data today, is actually in imaging. And then there's vast amounts of valuable information in the raw clinical notes and electronic health records and claims data that approaches like natural language processing and natural language understanding can help us make sense of and find meaningful information of to help solve some large public health problems. So let's say that you're a doctor. You're completely overworked. You see 20 patients a day. That's 100 patients a week. That's 5,000 patients a year. And on top of that, you have to keep up with all the latest medical research. So on the topic of cancer alone, there's been over 93,000 publications to date this year. How could you possibly keep up with that? So I think this is one of the biggest elements of where artificial intelligence is going to have a meaningful impact on healthcare, which is in aiding clinical decision making. Imagine if we could have an artificial intelligence tool that can summarize and condense all the latest medical research so that it can be meaningfully used by a clinician in his day-to-day practice. Imagine if we could have another model that can raise the level of care regardless of if you're being treated at Mass General Hospital or some small town clinic. And so it's not going to be doctors that are completely replaced by AI, but rather doctors who use artificial intelligence that are going to replace those who don't. Radiology is a great example of this. So say any of us go to the doctor complaining about some type of ailment. Either we've got knee pain or our back doesn't feel right or we're just under the weather. Typically, the first thing that a doctor is going to suggest is some type of test or scan to give them an idea of what's happening underneath your skin. So detection is really the first phase of care delivery. And a company out of Israel called Zebra Medical Vision has actually developed an artificial intelligence tool that can help detect lung cancer and bone diseases earlier than radiologists have ever been able to before. We all know, especially when we're talking about things like cancer, early detection can be the difference in saving lives. Quantitative analysis, or actually understanding the size and scope of a particular mass, is quite challenging for a radiologist to do, but it's really important in making an accurate diagnosis. So Brigham and Women's Hospital has developed an artificial intelligence tool that can do this measurement in seconds. It usually would take a radiologist to do this measurement usually 20 minutes, but that's now 20 minutes that they can build back in their day spending more time with patients. And there's incredible work coming out of the Mayo Clinic. So Bradley Erickson's group of researchers are actually using neural networks to see the unseen. So using only MRI data of brain scans of people that have brain tumors, neural networks are actually to pick up neural networks are able to actually pick up the subtle textures of a brain tumor that indicate the specific genetic mutation of that brain tumor. The only way that we've been able to do this in the past is with an extremely invasive procedure, a brain biopsy. And so this is really important because now we don't have to do that invasive procedure, but we can understand the specific cancer and then make the suggestions on how do we actually treat that with the correct medicines. But it's not just in imaging. Mount Sinai has developed a tool called Deep Patient. And what Deep Patient is, it's a neural network that's been trained with 70,000 electronic health records so that when a new patient comes in, it can analyze their entire medical history and make a prediction on the likelihood of up to 12 different diseases. And Cloud Medics has developed basically a real-time clinical recommendation tool. So it uses natural language processing on clinical notes in an EHR, plus deep learning on top of real-time diagnostics data that's coming off the bedside of the patient. And it's able to make real-time recommendations on diagnosis and treatment for the doctor. So it can say, hey, for this specific patient at this specific point in time, you should take this course of action. Drug discovery is another huge element of healthcare. It takes currently 12 years and $3 billion to bring a drug to market. That makes pharma quite literally the least efficient process in the world. So clearly, they're investing in artificial intelligence in many different ways to try and drive efficiencies into that process. So there's well-established use cases of deep learning and things like high-content screening, digital pathology, and real-world evidence, trying to pick up the weak signals that would otherwise be missed by scientists or clinicians. So consider this. 30% of all of our healthcare, it's predetermined. We're born with it. It's in our genes. 20% of our healthcare is actually what happens in the clinic and our conversations with the doctor and the suggestions that they make in terms of medicine or treatment. That means 50% of our health is reliant on things called social determinants of health. So where we live, access to education, access to healthcare programs, how far away we live from a Whole Foods. So that's why they say that your zip code is actually a better predictor of your health than your genetic code. So if 50% of our health is reliant on things that are outside of the healthcare system today, what impact can artificial intelligence really have? Well, I'm here to suggest that this is potentially one of the biggest areas where artificial intelligence can have an impact, because large payers, large healthcare providers, large insurance companies, they're motivated to try and keep people healthy. Healthier people are less expensive to insure, so it makes sense. So what if we can use all the data that we're collecting on ourselves as patients, from electronic health records, from clinical data, to prescription data, and then combine that with many new data sources, things like wearables that can actually monitor our vitals in real time, or actually detect subtle hints in our gait, which could be early indicators of some type of neurodegenerative diseases. Or maybe, for instance, this week, I think the FDA just approved the first digital pill that can monitor whether or not you're taking your medicines. So what if we can take both this traditional data and these new data sources and identify the subset of all of us that are likely to, say, get the flu this season, or perhaps those that are likely to experience some type of cardiac arrest? Well, that's what I believe that the future of healthcare looks like, because they say that great digital companies make great recommendation engines, and I think healthcare will come in the form of many different recommendations, leading us to make healthier decisions throughout our lives. And deep learning is going to be a powerful tool to do that. So at NVIDIA, we're extremely focused on trying to make deep learning more approachable for everyone. And that vision has really manifested itself in the NVIDIA GPU Cloud. So it's the most comprehensive deep learning software stack available. If anyone here has actually started to try and do deep learning, there's a lot of software engineering effort that goes into making sure that your drivers are all up to date, that you're using all the necessary libraries, that you have the latest machine learning frameworks available. And so we've taken that software engineering effort off of your shoulders and really made it as simple as going to an app store and downloading an app of your choice. So you can go to NGC today and download optimized versions of TensorFlow, MXNet, Caffe, load your data, and get right to deep learning. And obviously, NVIDIA GPU Cloud runs on AWS today. So you can go to the AWS Marketplace, download your NVIDIA Volta Deep Learning AMI, spin up your P3 instances, which are our latest GPU available in Amazon's cloud. They're basically supercomputers that you can rent for $3 an hour. And then obviously you can leverage the machine learning frameworks available on NGC. And if you're looking for further productivity tools, we've actually made Digits available for free as well. So Digits is a convenience package for deep learning. So if you don't want to get in low-level code and really just are looking for a GUI tool, Digits can help you select your data, load your data, access pre-trained models, visualize and monitor your training progress, make sure that your models aren't overfitting, that you're reaching the accuracy levels that you need, and then you can actually export that model to do inference as well. So there are still challenges that remain, and a colleague of mine wrapped this up pretty nicely in TLC. So talent, labels, and commitment. I think we've heard several times here at reInvent this week that enterprises just don't have access to the data science talent that they need. And as part of that, NVIDIA has developed basically an initiative that is geared towards bringing deep learning courses to the enterprise so that we can help your data science and your analytics teams start to solve problems with deep learning. Second is labels. A lot of the major breakthroughs that we've seen in artificial intelligence have come from supervised learning approaches, where we actually tell the computer what it is that they're looking at. And so there's a lot of need for labeling tools, data curation tools, to make sure that on your path to becoming an AI-enabled enterprise, your entire data lake is actually machine-learnable data. And lastly is commitment. And I think what we need is commitment and collaboration from leaders across the healthcare ecosystem to understand what artificial intelligence is, and maybe more importantly, what it isn't, so that we can actually realize the potential of deep learning as a powerful tool to hopefully produce some significant outcomes for all of us. So that's the wrap up here. Hope everyone has a good reInvent. I'll stick around for a couple questions too. Thank you.